You have a theorem, theorem 8.1. So 8.1 is the polygon interior angles theorem, and this is to find the sum of the interior angles. So if you add up the inside angles of a polygon, we want to know what is the total of that. This theorem says that the sum of the measures of the interior angles of a convex n-gon is n minus 2 times 180 degrees. N is the number of sides, and we'll do a couple examples with this. Remember, convex just means a closed polygon that does not cave in. So like a regular hexagon, pentagon, a quadrilateral, a triangle, things like that. And then the corollary to 8.1, this is just an add-on. The interior angles of a quadrilateral. Remember, a quadrilateral is a four-sided shape, so a square, a rectangle, a rhombus, parallelogram. The corollary says that the sum of the measures of the interior angles of a quadrilateral is 360 degrees, which you should know. You should know there's 360 degrees in a square because you have four right angles, or four 90-degree angles, and 4 times 90 is 360. Okay, so an example to practice theorem 8.1. We have polygon ABCD is a square, and we need to find the sum of the angle measures. So we want to know what is angle A plus angle B plus angle C plus angle D. What is the sum if I add all these measures? Now we're going to pretend that you're naive and that you don't know there are 360 degrees in a square. So in order to do this, we're going to use theorem 8.1, and with 8.1, there is that nice little formula where it says you take n is the number of sides, subtract 2, and multiply by 180. So the number of sides I have in a square are 4, and I need to subtract 2. And then I have to multiply that by 180 degrees. 4 take away 2 is 2. 2 times 180 degrees equals 360 degrees, which we already knew, but this just proves that theorem 8.1 does indeed work. Okay, next one. I want to find the sum of the angles in this polygon. So I need to find the sum of the measure of the interior angles of a convex hexagon. If you don't know what a hexagon is, count up the sides. There are 6 sides, but I want to find out what do all 6 angles add up to be. So I'm going to use my formula from theorem 8.1, n being the number of sides. There are 6 sides in a hexagon. So I'm going to do 6, take away 2, multiply by 180. 6 take away 2 is 3. And 3 multiplied by 180 degrees is 540 degrees. So that means if I add up all of the angles in this hexagon, they will equal 540 degrees. Now, in this case, this is not a regular hexagon, meaning not all the sides and angles are equal. So not every angle is congruent to each other. But if you add up all the angles in the hexagon, it will equal 540 degrees. Okay, now we're going to kind of use theorem 8.1 in reverse. So we want to find the number of sides of a polygon. We don't just want to find the sum of the angle measures. We want to use the angle measures in order to find the sides. So the sum of the measures of the interior angles of a convex polygon is 1,260 degrees. Classify the polygon by the number of sides. So I know that I have some sort of polygon where all of my interior angles add up to 1,260 degrees. So I know my equation to find the sum of the measures of the interior angles, same one from 8.1, and this time I know that it equaled 1,260 degrees. So this is really like an equation that I have to solve now. I have to solve for n. I have to figure out what does n equal. There's a couple different ways that you could do this. You could distribute 180 first, or you could divide by 180 so that you're left with n minus 2. I'm going to distribute, so I have 180 times n, which is 180 n, and 180 times negative 2, which is negative 360. And that equals 1,260. If I add 360 on both sides, (1,620 equals 180 times the number of sides divided by 180. And you get n equals 9. So this is a 9-sided polygon, and a 9-sided polygon is called a nonagon. Okay, example 3. I want to find an unknown interior angle measure. So find the value of x in the diagram shown. Well, first of all, I need to figure out how many degrees is my polygon. If I didn't know that a quadrilateral was already 360 degrees, I could use the n minus 2 times 180 and get the degrees in this polygon. But because I already know a quadrilateral is 360 degrees, I have that to work with. First, what I'm going to do is I'm going to take my 3 angles that I know. So 135, 112, and 71 degrees. I add those up and I get 318 degrees. And I know there's 360 total degrees in my quadrilateral, so I will subtract 360, take away 318, and I get 42 degrees. So x equals 42 degrees, my missing angle. Okay, I'll have you do this one on your own. You need to find the sum of the measures of the interior angles of the convex decagon. So how many degrees do all the interior angles of the decagon add up to be? Go ahead and push pause, and when you're ready you can push play and check your answer. So you should have used n minus 2 times 180. N is the number of sides. There are 10 sides in a decagon. 10 take away 2 is 8, and 8 times 180 is 1,440 degrees. So all of the interior angles of this decagon add up to be 1,440 degrees. I'll have you do the next one on your own as well. The sum of the measures of an interior angle of a convex polygon is 1,620 degrees. Classify the polygon by the number of sides. Push pause and push play when you're ready. Okay, so use n minus 2 times 180 and set it equal to 1,620 because you know the polygon is 1,620 degrees. When you distribute, you then need to add 360 to both sides. You're left with 1,980 divided by 180 degrees to get n by itself, and n equals 11. Now, because there's not a technical name for an 11-sided figure, we call it an 11gon. And I'll have you try this one on your own. You need to use the diagram to find the measure of angle K and the measure of angle L. Make an observation about K and L. What do you notice about them? And also you want to notice how many sides is this polygon. Go ahead and push pause and push play when you're ready. Okay, so first of all, you want to figure out how many degrees are in a pentagon. N take away 2 times 180. 5 take away 2 is 3, and 3 times 180 is 540 degrees in the pentagon. Then I needed to notice my 2 missing angles are congruent. So if I add up 68 plus 105 and plus 109 is 282 degrees that I've already used. Take that away from 540 and I'm left with 258. That's 258 degrees to split between K and L. And since they're both congruent, then 258 divided by those two congruent angles is 129 degrees for each missing angle. So the measure of angle K is 129 and L is also 129.